this is Algebra 2, Lesson 76. We're going to talk about using both substitution and elimination in a system of equations, and we're going to talk about negative vectors. We're starting on page 316. So we have used both the substitution and elimination methods to solve systems of equations with two variables. We're going to use both substitution and elimination to solve systems of three equations containing three variables. So here's our first example. Use substitution and elimination as necessary to solve this system of equations. We have three. For convenience sake, I labeled them A, B, and C, so it's easier to tell which one I'm talking about. So we have x equals 2y, x plus y plus z equals 9, and x minus 3y minus 2z equals negative 8. A gives us a nice x equals equation, so we'll start with that one, and we're going to substitute the 2y for every x in both B and C. So we're going to use both equations. So we will have, substituting the 2y into B, we're going to have 2y plus z equals 9, and 2y minus 3y minus 2z equals negative 8. So this is B and this is C. Alright, let's simplify this mess. We have 3y plus z equals 9, and we have that'll be negative y minus 2z equals negative 8. Okay, so now we're going to multiply, this is still B and this is still C. So let's multiply B times 2 and get rid of these z's. So that will be 6y plus 2z equals 18 minus y minus 2z equals minus 8. We can add these together. The z's cancel, and we have 5y equals 10. So y equals 2. Okay? Now we can substitute this 2 into the other equations and solve for x and z. So we'll start with A. X equals 2y, which is 2 times 2. So x equals 4. And let's use B. So we have 4 plus 2 plus z equals 9. So 6 plus z equals 9. So z is going to equal 3. And we can check this by doing it all three into the last equation. So we would have 4 minus 3 times 2 minus 2 times 3 equals negative 8. So this is 4 minus 6 equals negative 8. And 4 minus 6 is negative 2 minus 6 equals negative 8. So this is true. Okay? Okay, use substitution and elimination as necessary to solve this system of equations. So we have 2x plus 2y minus z equals 12. 3x minus y plus 2z equals 21. And x minus 3z equals 0. Okay, C only has two variables, so we'll start with that one and we'll solve for x. So x minus 3z equals 0. We're going to add 3z to both sides. And x equals 3z. Now we can substitute this into both A and B. So we have 2 times 3z plus 2y minus z equals 12. And 3 times 3z minus y plus 2z equals 21. So we have 6z plus 2y minus z equals 12. and 5z plus 2y equals 12. Okay, so this is A. We have 9z minus y plus 2z equals 21. This is 11z minus y equals 21, and that is B. Okay, now we're going to put these guys together and use elimination. And let's multiply B times 2. So we have 5z plus 2y equals 12. And 22z minus 2y equals 42. Add these together and the y's cancel. We have 27z equals 54. Divide 27 from both sides. And z equals 2. Okay, now we're going to substitute that back into the other equations and solve for the other guys. So we've got, using c, we have x minus 3 times 2 equals 0. So x minus 6 equals 0. So x equals 6. Okay, so now we have z and x. So we have 2 times 6 plus 2 times y minus 2 equals 12. 12 minus 2 plus 2y equals 12. This is 10 plus 2y equals 12. We subtract 10 from both sides and we get 2y equals 2. So y equals 1. And now we're going to substitute all three into our last formula. And I'm running out of space. So we've got 3 times 6 minus 1 plus 2 times 2 should equal 21. So we have 18 minus 1 plus 4 equals 21. 18 minus 1 is 17 plus 4 does indeed equal 21. So that's true. Okay? I like these. I think they're like a big puzzle, and I like puzzles. Okay, now we're going to talk about negative vectors. We have some diagrams on pages 317 and 318. In lesson 72, we learned that there is only one form of rectangular coordinates, but two ways to write polar coordinates because positive or negative angles can be used. So in this picture, we can see that the rectangular coordinates are 8.66 right plus 5 up. In polar coordinates, we could work this out and say that our polar coordinates are 10 at 30 degrees, because this is the 0, so this is 30 degrees up, so this is 10 at 30 degrees, or we could say it's 10 at negative 330 degrees. Okay, so there we learned two ways to do polar coordinates. While lines of magnitude, so this 10 is the line of magnitude, it's the distance from the origin to this point. While lines of magnitude only show distance from the origin, vectors also show direction. So, here we have another diagram. Let me pull it down a little bit. There's a shadow there. Alright, so here we have another diagram. If we start at the origin, facing 0, and we turn 210 degrees counterclockwise, this way, and then we walk backwards 10 steps. So we're starting here at the origin. What I need is a little person. Alright, what I have is a small dinosaur. So our dinosaur was standing at the 0, and he was facing 0 degrees, and he turns 210 degrees, so he's no longer facing that way, he's facing this way. Okay, And then he walks backwards 10 steps. So he's still actually right here. He's going to walk backwards 10 steps, and he's going to end up right there at this dot. I don't know if that description was helpful or not. It was handy. Okay, so we started at the origin. We turned our body, so instead of facing 0 degrees, we were facing 210 degrees, and then we walked backwards 10 steps. And now we are back on the same point. But we could describe this point at -10 at 210 degrees. Okay? So we were at 210 degrees, and then we walked backwards 10 steps. So in this case, our magnitude is now a vector. It's showing direction and not just distance. And of course, if we measured this angle from this way, it would actually only be -150 degrees. So we could call the same point -10 at -150 degrees. So now we have 4 ways to describe this point. This point could be described as 10 at 30 degrees, 10 at -330 degrees, -10 at 210 degrees, or -10 at 150 degrees. Our rectangular coordinates will be the same for all 4 of those, but the vectors changed, so the polar coordinates changed too. Okay, so here's our first example. We're going to add -4 at -20 degrees plus 5 at 135 degrees. So we're going to start by drawing the vectors. Here's the first one. Okay, it says -20 degrees. So that is down here. Actually, it's really over here. Okay, sorry. So here's -20 degrees. So we're going to stand at the origin, turn facing -20 degrees, but then we're going to walk backwards 4. So our angle is actually going to look like this. Okay? Because this is 20 degrees from the axis to here. This is also 20 degrees from the x-axis to here. So this is 20 degrees. Here is our right, and here is our up. Okay? Let's draw the other vector, and then we'll find rectangular coordinates for both. Okay, here's our graph. We're starting at the origin. We're turning 135 degrees, which would be past 90 and another 45 degrees, so it's right here. And we're going to go 5, distance of 5 degrees. So if this angle is 135, then this angle from the x-axis is going to be 45. Right? Okay, now we need to find our rights and our ups. We're going to find our right on this side by finding the cosine of 20 degrees times 4. So 4 times the cosine of 20 degrees is 1.37. 4 times the sine of 20 degrees is 3.76. So on this one, our rectangular coordinates are going to be 1.37 to the right, and this is quadrant 2, so this is negative, plus 3.76 up. We're in quadrant 2, so the up is positive. Okay, over here, we're going to find 5 times the cosine of 45 to find our right, which is going to equal 3.54, and 5 times the sine of 45 degrees to find our up, which is also 3.54. So the rectangular coordinate of this is 3.54 right, and we're in quadrant 2, so that's negative, plus 3.54 up, and in quadrant 2 that's positive. And now we can add these vectors together. So we have negative 1.37r plus 3.76u. And we're going to add 3.54 right plus 3.54u. And so this is 194 right plus 0.137 up. Did I do that backwards? Yep. Sorry. This is 3.76. This is 1.37. This is what happens when I look at my notes wrongly instead of doing it live. So this is negative 3.76 right plus 1.37 up. I'm just going to switch these guys. 3.76 negative positive 1.37, and really all that does is flip these guys. So we have negative 7.3 up, no, right, plus 4.91 up. Sorry. Alright, that is indeed your answer. Okay, your book is leaving it in this form. In previous examples, we've said that if you start with polar coordinates, you need to go back to polar coordinates, but this is what your book wants for right now. So we're just going to leave it like that. If we were going to change this back to polar coordinates, then we would draw this angle, right? So if this is 4, then this is 8, so this is going to be in here somewhere, and we're going to do 4 and 8, so this will be somewhere right around here, and this angle. So if we were going to figure this angle out, we would say that this was 4.91, this is 7.3, and we would find the magnitude and the angle, right? So we know how to do that. Your book left it in this form, so we're going to leave it in this form too, even though that drives me crazy. Okay, so that's it for that lesson. Try your practice problems. Let me know if you have any questions. Do all the problems for this lesson. Thank you.